In today's session, we will talk about file descriptors. So one very important technique, if you get a good hang of it, then pretty much with any command you can tweak the input, the output, or the error messages. So by tweaking I mean you have a complete control on where from the input comes for a given command, where the output goes, and where one can redirect the error messages, provided you should understand the file descriptors. In Unix, the user normally works with three types of devices, namely the standard input device. The standard input device is keyboard, and for the standard input device keyboard, the symbol is less than sign or 0 less than. Now this one is a file descriptor for input. So normally the input comes from where? The keyboard. So if you see most of the Unix commands, the input for a given command would come from the keyboard. So if I don't want to use a keyboard, then I can input redirect some file instead of the input being provided from the keyboard. In general, there is a standard output device, which is your monitor, console, or screen. It can be indicated with a greater than sign or as well with 1 greater than. Then there is a standard error device also. The standard error device is where the errors are redirected. You see those errors on your monitor, on your console or screen. It can be depicted using 2 greater than symbol. Now if you know these file descriptors well, then you can pretty much take care of any redirection to any file or any other device for that matter. For example, let's say I am talking about some command cat, which shows the contents of a file on screen. Instead, using output redirection, I could have redirected it to my device named printer. So I would have said cat some file followed by an output redirection symbol to /dev/printer. So whatever is there in that file will get printed as if it's the output redirected to a printer. So with these file descriptors, one gets the ability in Unix to read the input from somewhere else instead of the standard input device keyboard, to redirect the output to somewhere else instead of the standard output device, the monitor. You also get an ability to control where your error messages would appear. By default they go to your screen. You can redirect them elsewhere, provided you know how to use this. Most commands take input from the standard input device. For example, cat command by default takes the input from keyboard and then echoes the same keystrokes on the screen, because screen is the standard output device. So the default behavior of cat is accept the input from standard input device keyboard, redirect the output to the standard output device monitor. Now what if I want to change this behavior? Almost all the commands displays the output on standard output device. Cat by displays the accepted input from keyboard on the screen. So let's focus primarily on understanding standard input and standard output device. So see here I am showing a quick demo on cat. So if I say cat only without any file name, without any input output redirection, then I said hi there. So the input, it's waiting for my input. The input is going from the keyboard. The moment I say end of input enter, see what happens. It displays the same keystrokes onto my screen. So accepting things from standard output and echoing it onto the standard output device is what is the default role of cat command. So input comes from the standard input device, output goes to standard output device. Now consider this case. I said cat less than indicates what? Standard input or input redirection. So I can use less than sign to redirect the input. Now in this case I said cat followed by input redirection followed by some file name. Now the input is not coming from the standard input device keyboard. Instead it's coming from a file. Name of the file is second.txt. So see here. I said cat less than sign, which is for input redirection, emp.txt. So understand what it means first. If I say cat and file name, it would display me the contents of the file. But in that case, the emp.txt was an argument to the cat command. Here, normally when I say cat, what happens? It expects the input from keyboard. Here I am instead saying expect the input from a file. What I told about output? Nothing. At least my command doesn't talk about anything on the output. So default behavior for output will apply for cat command. Default cat behavior for output is whatever comes from the input, it displays it onto your standard output device. Well, I haven't played in this command with the output part of it. That's why the output is still coming on my screen. But input, I have, instead of taking it from a keyboard, I am accepting the input from the contents of a file, in my case emp.txt. One could have also said something like this. Now see how it works. See what I said? Instead of reading the input from standard input device, the keyboard, read the input from the file emp.txt. Path is missing, means it will assume the current working directory. Then the default behavior of cat command is to display it onto the standard output device, which I categorically have redirected in this case to a file. By this I mean, do not display it onto the standard output device. Instead, redirect it to a file. The name of the file is copy emp.txt. So whatever otherwise was going to be sent to my monitor is now being sent to the file copy of emp.txt. If I check both the files, they are exactly identical. So it's like copy command. What copy command does at a file level, I have done it at a contents level. So I read the contents from emp.txt using an input redirection. I redirected those contents to standard output device in general, but in this case I have redirected it to a file copy of emp.txt. So it's a content copy of a file. So I have redirected successfully input as well as output. People say, is there any precedence of those operators? So see here, I said cat redirect the output to copy.emp by reading the input from emp.txt. So is there any change? So sometimes I might have used a less than sign before and a greater than sign afterwards. And in this case I have used the greater than sign before and a less than sign at a later point. But the command still has the meaning preserved, which means whatever is the output to the cat, instead of sending it to the standard output device, the monitor send it to a file copy of emp.txt. If I stop here, it will start accepting the input from keyboard. Now I said don't accept it from the standard input device, the keyboard. Instead read the input from the file emp.txt. So simply by changing the position of those angular brackets didn't make any difference, at least in this cat command. Now understand this. I am in my home directory. I said ls. These are the files in my home directory. By any chance, do you see any file called as XLS? No. So see what happens when I type this command. I said ls show me all the files with the extension .txt and with the extension .xls. See what happens. For txts it has displayed me the output, but for errors it has, for a file called as .xls, since there is no such file with the extension .xls, it has shown me an error. Now understand in this case how the things are working. For star.txt there is output. For star.xls there is an error. But my standard error device is same as that of my standard output device, that is the monitor, the screen, the console. Clear? So output came to the screen, errors also were reported to the screen, because both the standard output device and the standard error device is monitor by default. The console attached to your machine, the screen attached to your machine. Now if I redirect the output of this command to some file, see what happens. I said output.txt. What came to your screen? Error. Where is the output? Output has gone to a file called as output.txt. But errors were not redirected. So this is to prove that collectively this is not the output. Output is this much and this portion of it was errors. That's why when I redirected the output, error still came to the screen. Output has successfully been redirected to the file. Clear? So by default the standard error device I said is a screen. Now see what if I wanted to redirect output to a separate file, errors to the separate file. So I said this. I want my output to be captured in output.txt. I want my errors to go to errors.txt. Now there is nothing on my screen. Clear? So I redirected the output of that command to the file output.txt. I have redirected the errors to a file called as errors.txt. Let's see. Errors.txt. See here. The error was captured in the file. If I say output.txt, the output was also captured in a file. So understand this. You have an ability to redirect input, output and error messages. Consider another example. So in this case, output is redirected to output.txt, errors are redirected to error.txt. Now what if I want to redirect both to the same file? See here. I am deleting my previous output.txt and errors.txt. I want both output and error should go to the same file. See here. So I am using the command ls star.xls. What should I write here? Instead I will call the file name as output.error. Means it contains both. Then to redirect the errors we use 2 greater than followed by the file name. So file would be same. Earlier it was output.txt and errors.txt. This time I will be using only one file because I want both the output and errors to go to the same file. See what happened now. What does the output.error contains? Only output. Where is the error? Understand this. I said star.txt star.errors. Output should be redirected to out.error. Errors should also be redirected to out.error. Some errors may get truncated when both the output and errors are redirected to the same file in the above fashion. Then how should I redirect it if I want to capture both in the same file? There's an alternative available. The correct way of redirecting it is to say see here. I said ls star.txt star.xls. the output of this command should be redirected to output.error. What does this indicates? Error redirection. I said error should be redirected to %1. Now who is 1? Standard output device. So I said wherever my 1 is going, send my 2 to the same location. So wherever my 1 is going. Now 0 indicates input, 1 indicates output, and 2 indicates errors. So in this case I am saying send my errors, redirect the errors to the same location where 1 is going. Now where is 1 going? In out.error. So let's see what happens when I use it this way. It's not with a space, by the way. This way. Now if I check my file, error was captured followed by the output. So to redirect both errors and output to the same file, the convention is this: redirect the output followed by 2 greater than %1, which indicates redirect my errors to the same location where my standard output is getting redirected. Now sometimes you may not be interested in the output. You are just interested in the errors. Sometimes you may be only interested in the errors, not the output. Sometimes you may be only interested in output, not the errors. Then what to do? See here. The basic purpose of applying this command is to ensure that I don't get any error. So I am not interested in the output. The basic purpose why I am applying this command is to check whether or not this command errors out. So I am only interested for the moment in the error. I am not interested in the output. So I said if I don't type anything further, both the output and the errors will come to my screen if at all there is any error. If there is any output, then both will come to my screen. I am not interested in the output. So redirect the output, don't let it come to your screen. So I said 1 greater than, or simply saying greater than, it's one and the same thing. Then I want to redirect the output to somewhere so that it doesn't pops up on my screen. People say redirect it to some file because you are not interested in looking at the output on the screen. Well, I am interested in the error. Don't redirect the errors. Errors will by default come to your screen. See here, I got the errors on my screen. Output was redirected. What should I do with this file now? People say anyways you are not interested, remove it. Right? Instead Unix provides you a special device called as dev null. If you redirect something to dev null simply listens and discards it off. It simply listens from one end and discards it from the other. It's a device. See what type of a device is this? It's a character special device. So it's not a file. File has size, whereas devices has major and minor identification numbers. So 1, 3 is 1 is a major number, 3 is a minor number. But you see this is a device, it's not a end user's file. It's a character special device in this case. So if you are not interested in capturing something in a file, you want to simply discard it off. Redirect it to dev null instead of redirecting it to a file. Because file has to be deleted later because I was anyways not interested in the output. So see here how I do it this time. Instead I said redirect the output to dev null. See what I got on my screen? I only got the errors. Output was redirected to dev null. What has dev null done with that output? It listened from one ear, it discarded it from the another. We have a saying. So redirecting something to dev null will simply accept it and discard it. Now sometimes I am only interested in the output, I am not interested in the errors. Now see here what happens. So I got output and errors both on the screen. Now I am not interested in errors. I am only interested in output. So I said 2 greater than, which is the standard error device, slash dev slash null. See what I got on my screen? I only got the output. Errors were redirected to dev null instead of redirecting it to the file, because I was not interested in what error message is there. Sometimes you are not interested in output and you are not also interested in errors. Then people say, why do you run the command? Just to check the exit status. See here. What happens when the command runs successfully? It's another important learning. If I type ls, the command was successful. I said echo dollar question mark to find out what is the exit status of that command. Exit status. If it prints 0, that means the previous command was successful. What was previous to this? ls. That means ls command was successful. I said pwd. I said echo dollar question mark. That means previous command was successful. I said ls star dot txt. I said echo dollar question mark. It says command was successful. Now see here. I said star.txt star.xls, and then I say echo dollar question mark. It says the command was exit status indicates any value other than 0. It means the command has failed. People say, no, the command has never failed. There's an understanding gap when I say. People say, no, the command has not failed. The command was successful, but in the directory there was no such file xls. That's why it has shown you an error message. But see, there were files with the extension txt. That's why it produced the output. But for you, why would somebody type star.txt and star.xls? With an anticipation, with an assertion that you believe that there is some file with the extension txt, and that you believe that there is some file with the extension .xls. The assertion behind that has failed. That's why the exit status is non-zero. So understand this. Now I said grep cut as a word, by the way, in words.txt. It found that word. Now I said echo dollar question mark. How was the command? 0 return value from a exit status of a previous command indicates a successful execution. Any non-zero value indicates a failed execution. The command may or may not have failed, but the assertion behind it may have failed. Now see here, I said grep Pune in words.txt. What happened? No output. I said echo dollar question mark. See what it prints? Exit status as 1, meaning the command has failed. Now people say, no, the command has not failed again. There was no pattern named Pune in the file words.txt. That's why it never produced the output. Why would somebody have typed grep Pune in words.txt? With a belief that there is indeed a word Pune, pattern Pune in words.txt, and I want to see the lines containing the pattern must have been the basic objective behind typing the command. The assertion behind the command has failed. The command itself is successful. It has not printed anything. So understand the difference between a successful execution and a failed execution. Whenever the return value of a command exit status is 0, that means the previous command was successful. When the exit status of the command returns any value other than 0, that means either the command or the assertion behind the command has failed, which is treated as with an exit value of some non-zero number. So see here, coming back to my topic, I said sometimes you are not interested in the output and you are not interested in the errors also. You are only interested in whether my command was successful or whether it was a failure. See here, I am not interested in the output. I am not interested in the errors. Let me redirect the output to dev null. I am not interested in errors also. So let me redirect the errors as well to dev null. And then I simply say, was my command successful? So certainly in this case, my command wasn't successful. Clear? So sometimes you are neither interested in the output, you are not interested in the errors, you are simply interested in finding whether or not this command would run successfully. Clear? So this is another important know-how that you must have. That is to find out an exit status of a command. Echo dollar question mark applies to the immediate predecessor command and it reports the exit status of the immediate predecessor. See here, I said pwd host name ls echo dollar question mark. Now the exit status is for pwd, host name or ls. It is only for ls. So echo dollar question mark only displays the exit status of the predecessor command. Any pre-predecessors, I should have typed it then, not now. It's too late for me to type and find out what was the exit status of the pwd command or hostname command. If I want to check, I should check it now afresh. My command was successful. Clear? So very important. Sometimes you may not be interested in the output. You may not be interested in the errors as well. Both the output and the errors are redirected to the same file dev null. Dev null is a special device file which accepts the input and simply discards it. So it simply accepts it and simply discards it off. So very important discussion, because now this gives you an absolute flexibility. Whether the input should come from keyboard, whether the output should go to monitor, whether the output should go to error should go to the monitor or to a file. People typically use this to print. So typically we say, if I want to print a file, I say cat resume.txt. If I stop here, where will be the output going? Standard output device. Then I say dev printer 0. So it will redirect the whole output to the printer and you will get a printout. So this gives Unix the ultimate command line flexibility to tweak the input, to redirect the output and to redirect the error messages. So if you have understood this concept, going forward in shell scripting, your life would be very easy. For example, somebody said, if there is a pattern named Pune in the file word.txt, then display a custom message, pattern found. Else, display a message, pattern not found. But what is the grep ka behavior? If a pattern is found, it prints the line containing the pattern. If the pattern is not found, it's silent. It doesn't say anything. But what I want to change the behavior. I said, write a program to run a grep command to find pattern Pune in words.txt. If pattern is found, I should not see the lines containing the pattern. I should instead see a message saying pattern is found. If a pattern is not found, it should not be silent. It should print me a message saying pattern not found. See how I am writing it now. But it's irrelevant for you for the timing, but I wanted to convey it. So I said grep Pune in words.txt. If the pattern is found, it will produce output to my screen. I am not interested in the output. Clear? If the pattern is not found, it anyways does not print any error message. So whether or not I redirect the error is immaterial in this case, because there, even if there is an error, I mean even if there is the pattern is not found, then also it's getting redirected to something else. So although it was not mandatory in this case, I have still written it. There is no harm writing it. Then I said, if the exit status of the previous command is equal to 0, then the pattern was present in the file. Else, the pattern was not present in the file. Followed by end of if. So see what happens if I run this thing now. See what is my output? The output is pattern was not found. If I change this to cut, see what happens now? The pattern was present in the file. So instead of getting the standard output from a command, which was the grep's default behavior, grep by default prints you all the lines that contains the pattern. Instead I have changed the behavior to something else. Clear? So this gives you an ultimate flexibility. Otherwise people, they fail to visualize. Why would somebody be not interested in output and errors? Then why to type the command if I am not interested anyways? So this is to make a decision on the behalf of the execution of the command. So I made a decision. If the previous command was successful, that means pattern is there. If the previous command has exit status other than 0, that means the command has failed, either in execution or in the assertion. In either case, I want to print a message, the pattern was not present in the file. So you have tr, which acts as a translate, which is another command in Unix. See what tr allows you to do? tr allows you to transform the case. For example, see here the file words.txt. All of the words are mentioned in lower case. See how I could have used tr command to translate the case. I would have said tr a to z See what has happened. Try to understand what type of expression is this one. tr in its most generic format, it would be written like tr followed by options followed by expression 1 followed by expression 2 file input redirected. By the way, tr command does not accept file as an argument. It always expects the file to be input redirected. Very important. So see here how the file was input redirected in this case. So understand this. What is the option here? There are no options. What is expression 1 here? Lower a to z. What is expression 2 here? Capital A to z. When you give expression 1 and 2, it will transform expression 1 by using suitable characters from expression 2. So see what I have done. The file earlier had all lowercase words. And then we say whatever is there in expression 1, basically we have mentioned a range. A to z to their capital case equivalent A to z. Here it acts as a transformation. So what it has transformed? It has transformed all lowercase alphabets between A to Z to their uppercase equivalents capital A to Z. Consider another case. I said tr followed by C followed by D from words.txt. See what happened? So whatever are the characters from expression 1 are transformed to the characters that you mentioned into expression 2. So I said T, see what happened this time? C was replaced with D, but there was no substitute mentioned for T. So what has it taken in that case? The square bracket. What if I remove those square brackets? See what has happened in this case? C was substituted with D and T was also substituted with D. What if I 1 here and 2 here. Obviously the other one is mismatching. There is no equivalent from the search expression, so there is this equivalent to this is not found, so it never came into the effect. So in this general format, TR works for transformation. It's a character by character substitution. Remember, character by character substitution. I am opening jumble.txt. Then I said tr, replace the word cat with mat from jumble.txt. Before I run this, see what happened. Has it worked in the same way that you have expected? This is my original file. Has it worked in the same way that you would have anticipated? REPLAC was replaced with M. The word here, there was cat, so C was replaced with M, A was replaced with A, T was replaced with T, with mat. So remember, it's not by word substitution, it's character by character substitution. Now you never noticed it because at the end it was 80-80, that's why. Otherwise all the characters in the first expression would have been replaced by their equivalent characters in the second expression. Second use of tr command. Tr can be used to delete certain characters from the file. See here, this is my file emp.txt. I said tr-d pipe from emp.txt. See what happens. It removed, deleted all the field separator pipes, whatever was there. That's why you see the pipe is missing. Now the first two fields are tightly integrated. Clear? What if I say further JS? Now notice this. Before that, let me print the file. So what has happened? It has deleted from any given line pipe, J and S, all of it. So it was Adams earlier, now it is Adam. Pipes were replaced. Here it was salesman, S got dropped, deleted, because S is as part of my. So it's never a word dropping, it's a character by character deletion from the input. Now it can also suppress multiple consecutive occurrences of a given character to a single occurrence like this. See here. Actually it's one line only, but I put lot of spaces after space. See how it appears. I am using set line numbers. Okay. Now see how I can use. So what are the multiple consecutive characters in this case? Space. So see how I can use it. The original file is new.txt. Now I can say tr-s S is to suppress multiple consecutive occurrences of a given character to only one occurrence. Which is that character? I said space new.txt. See what happened? Multiple consecutive occurrences of space was reduced to only one occurrence. I said Mississippi and there I said tr-s. See what happened? From wherever there was SS, multiple consecutive occurrences of S were replaced with a single occurrence. Multiple occurrences, consecutive occurrences of S were replaced with a single occurrence. So we would typically use this to chop off unwanted spaces. Why would you use this in real life? To remove the spaces. But you can remove any character is what I mean. Suppresses multiple consecutive occurrences of a given character to a single occurrence is what is the option -s. Replace characters with some substitute. So I said James should be replaced with short. So don't expect the word will be replaced. Instead, what will be replaced? J will be replaced with S. A will be replaced with H. So character by character replacement. In some cases, you can use it for complementing the deletes. See here by what I mean by complementing the deletes. We used earlier D to delete something. So I said tr-d pipe from emp.txt. So all pipes were removed. Similar way I might have used as. So all A and all S's were removed from the file. Now see what happens when I say cd. What it has printed? Everything except A and S was deleted. What remained in the file is this much only. So everything except AS was deleted. Reverse of D is CD. Where D deletes only those characters, CD deletes all other characters except those characters. So D is for deleting the characters, C is to complement the delete, and S is to suppress multiple consecutive occurrences of a given character to a single occurrence. So it could be a very handy technique during shell scripting. Typically this is what happens in shell scripting. I ask a question to the data entry operator. Do you want to live further? And I expect him to type some answer, which I am capturing it in this one. When I run this, he might type yes, no. But see what could be the problem here. Then I am examining his answer. So I have written a simple decision making in my shell script. So I said, do you want to live? I am expecting that user to type some answer, which I am capturing in a variable called as my answer. And then depending upon his answer, I am making a decision. If he types yes, he wants to live, I am saying good for you, you should leave. And if he types no, that he does not want to leave, then I am saying when are you planning to die then? So I am writing it as a shell script. See here. And now see what is the problem with this shell script. I said leave.sh. See what it says. Do you want to leave? It's waiting for my input. I said yes. Then see what it says. When are you planning to die then? What we would have anticipated, what it should have prompted you? Yes, you should leave. It's good for you, you should leave. But why it didn't pick up my answer? Because I compared with capital Y small es. While typing the answer, I typed it all in lowercase. There was a case mismatch and it couldn't pick up my correct answer. But if I run the same thing by typing yes, then it says. Then I said yes, I want to leave. But see what it says. Now when it comes to such decision making that you don't know what the user is going to type, it's always better to transform his input into a particular case and then check it. Now see what happens if I modify this script. Let's not worry what I am doing. You will anyways realize these techniques at a later time. What I am doing, whatever is his response, I am applying tr command to convert all lowercase characters into the uppercase equivalent. And then in my decision making, I simply say check it with capital case yes. Now see what happens if I run the program. I said yes, all lowercase. Probably some problem in the way I typed it. Well, I should have checked it against modified response. But anyways, that was not the error. The error is something else. He says, I found something missing. Let's check it. We'll realize. It says there was end of line, probably whatever. There is a missing quote here. Now he said lowercase yes. See? Now he says uppercase yes. See? Now he says mixed case yes. See? So this is when you can make use of that tr command to transform. Otherwise you would have to write up multiple cases. If it is capital case yes, or it is lowercase yes, or it is capital Y small es. If it is capital Y capital E small s. So you would have to test, otherwise too many possibilities for the user input. You could instead transform the input to something else and then effectively do only one decision making. And that is, if you want to leave, then whatever is the alternate action. So tr command could come really handy in your life while doing shell scripting, especially when it comes to taking a decision on the basis of input provided by the user. You never know, the user may be rational or an irrational user. He may give you the correct input and might be, मैंने तो ऐसे ही टाइप किया था, फिर भी आपका प्रोग्राम मुझे गलत आंसर दे रहा है. It's never that the program is giving you a wrong answer. Now clubbing multiple commands on the same line. How one could club multiple commands? The first one. So see here, multiple disjointed, which is disconnected commands on a single line. How I could put? Multiple logically disconnected commands can be mentioned on a single line, each separated from other with a semicolon. So typically, if I would have to type these many commands, ls, pwd, host name, date, I would have typed it all on different lines. It's not mandatory though you can type all of them on the same command prompt, provided the command themselves should be separated with a line termination character semicolon. So I said ls pwd host name date. Well, is ls dependent on pwd or pwd dependent on ls in this case? No. Is hostname dependent on ls, pwd or date? Is date dependent on ls, pwd or hostname? That's where I said there are multiple disjointed, disconnected commands on a single line. So they are disconnected, they are disjointed, but they are still on the same line. So you can club them together on the same line by putting a semicolon as a line termination. So it acts like ls, line termination, new command, line termination, new command. So it's as good as you typing something on the same line. Now how do I know? We have put a semicolon which acts as a line termination here. How do I know? Because here is the output of ls, here is the output of pwd, here is the output of hostname, here is the output of the date command. So it produces one output, although you don't have to wait for the new line to come and type the command there. Now another interesting thing is multiple commands which are logically connected. Now here it was completely disconnected set. Now I can logically connect them using and or kind of decision making. See here, one command can depend on another if they are logically connected. This is also called as conditional execution. If I say command 1 $& command 2, see what it means. Run command 2 only if command 1 is successful. And now you know what you mean by successful execution. If the exit status of a command is 0, that means it's successful execution. So command 2 would run when? Only when my command 1 is successful. Whereas the another notation is command 1 double pipe operator command 2. In this case, command 2 would only run if command 1 fails. So see here, I said grep Pune in words.txt pipe echo pattern not found. See what I said? What will happen if this command fails? What will be the output? What will be the output of this command? No output. But if I check the exit status of it, it will print me any value other than 0. If the command fails, automatically it will run the second command, echo pattern not found. See what happens? If I type only this much, I don't know what has happened with the command. Clear? So see, when command 2 ran only when command 1 has failed. Now I am saying grep cut in words.txt echo pattern found. If I don't do this, then the output will also be printed to the screen. I am not interested in the output. Instead, I am interested in the message. See what happened now? I said check for the pattern cut in words.txt. If it is found, what it will do? It will print the line containing the pattern. But I am not interested in the lines containing the pattern, so I redirected the whole output to dev null. And then instead I said run command 2. When would command 2 run in this case? Only when command 1 was successful. Now I change this thing to Pune. Command 2 never ran in this case. Why command 2 never ran? Because connection operator is $&. Command 2 would only run if command 1 was successful, and in this case command 1 itself has failed, so it will never run. So this type of association is called as conditional execution. People say, how many times I can put this thing? Any number of times, as long as you you could successfully read the command. You can put any number of and, or, and, any number of times. I am now trying to club them together. See here. I said grep Smith in emp.txt. If the output is found, redirect it to dev null. And then instead print, yes, there is an employee named Smith. Else, print, there is no such employee. Now tell me, when would command 2 run? Command 2 would run only when command 1 is successful. Means when the pattern is found. Tell me when command 3 will run. Only if command 2 fails, then only the third command will run. See here. Remember, Smith is there, but all in uppercase. So I said grep Smith in emp.txt. I am not interested in the output even if it is there. Instead, print me a message, there is an employee if a pattern is found. If the pattern is not found, then print a message, there is no Smith in the file emp.txt. So I have clubbed together both, all on single line. I change this and instead I make it as Smith in capital case. See here. Now since the second command ran successfully, the third command would never run. Clear? So very important, conditional execution. Multiple commands which are logically connected. How to determine the command was successful or not? Immediately after the command run, echo $question mark. $question mark gives you the exit status of the previous command. If it prints 0, it means the command was successful. If it prints non-zero, that means the command or command's assertion has failed. And this is what I have explained you until now. There is a third way to connect commands, which is multiple commands supplementing each other. Now in this case, the previous case, the command will run or not run depending upon the operator that you use and the exit status of the previous command. So it only, here in this case, command 2 is never concerned about command 1's output, right? It was only worried about exit status. Here in this case, command 2 was never worried about the output of command 1. It was only interested in the exit status. Now in this case, the next command is interested in the previous command's output. See here. I said ls tar.txt, too many of them. I said c star.exe. Clear? Now think of a requirement where I said, tell me count wise how many files are there with the name starting with C, ending with .txt. I am not interested in the output. I am interested in the count. So see how I can do. I said ls c star.txt, it prints me. Then I said wc-l. See what it prints. WC को कुछ input लगता है. Now see how it is working in this case. In this case, it's called as a pipe. To be very precise, it's called as a pipe without a name. It's also called as an anonymous pipe. Anonymous means with no name. So this pipe has no name. That's why it's called as an anonymous pipe. See how it works. Output of command 1. This was the output. Goes as input to command 2 because there is a pipe in between. Then WC acts on the output of that command, and what it is doing instead? Word count the number of lines. Actually, although the output is formatted as columns, but line wise, if I redirect, you will get to know. If I redirect it to some file, how many lines are there? 2. So it's as good as saying lsc star.txt redirect the output to output.txt, and later on saying show me how many lines are there in output.txt. We managed to club them together using a pipe operator. So understand this. One command can provide its output to the other command. The other command treats this as the input. Then processes it in some way and produces its own output. So output of ls command was given to wc as input. WC processed it in some way and it produced its own output. That output here is 2. Clear? Such commands can be added in a pipeline. A pipe is a data structure which facilitates IPC. IPC stands for inter-process communication. So when I typed ls, it must have resulted in ls is a program. Program is a dead code on disk. When you execute it, the program code is read and put into memory. It results into one or more than one processes. So one process was ls. The output of ls process was given to another process wc, and that's what I have facilitated what? IPC, inter-process communication. Since there's no name given to this pipe, that pipe operator is called as an anonymous pipe. A pipe device can be created with a name, in which case it is called as a named pipe. See here now, I am creating a device this time. I think we already have one. See here, there is a device. What is the first character shows in this case? P. P is a pipe. So here this pipe has a name. What is the name for this pipe? Pipe 1. That's why this pipe is called as a named pipe. And our pipe, does it have a name? This one, does it have a name here? That's why it's called as an anonymous pipe, a pipe without a name. Then you can make use of that anonymous pipe by saying command 1 pipe, command 2 pipe, command 3 pipe. Keep on doing this. The general behavior of a command is, if I don't use a pipe, command will accept input from standard input device. Command will display output to the standard output device along with the errors. But when the commands are put in a pipeline, output of any intermediate command will never be printed to the screen. Intermediate commands only. Only the output of last command will be printed on the screen. Then how does it work? It runs from left to right. Command 1. Command 1 will run, will produce its output, but the output is not going to your standard output device now. The output instead goes to the next command in the pipeline as a input. The next command processes that input, produces its own output. Will it go on screen? No, because there's one more command in the pipeline. So the output produced by command 2 goes to the next command as an input. The next command processes it in its own way. Now, will the output produced by command 3 go to the screen or to where? In this case, it will go to screen because there is no more command left in the pipeline. Just to give you an analogy, see here. From my current working directory, I am only interested in finding the name of directories present in my current working directory. I want only the names of directories. Is there any command to accomplish this, which will only print the names of the directories? No. It prints all files and directories. See how I can accomplish this using a complex pipeline structure. From the output, tell me which are the directories. Countries is a directory. Countries new is a directory. How came you know? Because this starts with the alphabet in the first column as D. You know filtering command grep for pattern matching. See how I can use. I said ls-l, it would have produced me entire output the way it has now. Then I said grep caret D. What it will do? Search for the pattern at the beginning of the line which contains D. If I stop here, see what I get. Clear? I only got directories filtered. Well, I was not interested in the whole thing. I was only interested in the names, not other attributes. I am further modified. tr-s, what it will do? Multiple consecutive occurrences of space will be reduced to one occurrence. See how the output looks now. Even if there would have been uneven spaces between the fields, even if there would have been. In our case, were there any uneven number of spaces between the fields? No. But even if there would have been, it would have removed all those multiple occurrences of space to single occurrence. Then I further say cut -d space as the delimiter, field as field 9. See what I got? Only the names of the directories. See how it is working again. If I see ls-l, I get this useless output. I am only interested in directories. So I further piped it with grep -d. What would -d do with grep? It will only filter those lines that starts with a D. D means a directory. This is what you wanted. Well, if I stop here, it will produce this meaningless output. So I am not interested. Probably column 1, column 2, column 3, 4, 5, 6, 7, 8, 9. Those 9 columns could have been separated from each other with uneven number of spaces. Example. How many spaces are there here in between every column? Single space. But see the immediate next line. How many spaces are here? Multiple. So what I am saying, if there are multiple spaces in the field separation, compress them to a single space. And then I am making a decision saying cut. Cut will vertically cut the file. Delimiter as space. That space I have given within single quote. And give me the field number 9. Field number 9 is this field. So see what it printed me. Clear? So complex things can be achieved using pipeline. Now can you say cut is an independent command? No. Cut actually depends on tr. Is tr an independent command in this case? No. tr actually depends upon grep -d. Is grep -d an independent command? No. It depends on ls-l. So they are interdependent commands which facilitates inter-process communication. How many processes I am talking about here? 4. ls, grep, tr and cut. People say, what if I wanted to have only the count and not anything else? I would have further said this thing. But then why to eat it this way? Isn't it? A easier alternative would have been, then why to do tr and cut and then further count it? See, there are two ways to count buffaloes in a stable. I keep on telling this in every batch. This is one way of counting the buffaloes in the stable. And this is another way. Sorry, this is another way. So there are two ways to count the buffaloes in a stable, in a farm. Number 1, count them by head. 1, 2, 3, 4, 10 buffaloes. This is counting the buffaloes by head. And there is another way to count the buffaloes. Sit down, count how many legs are there and divide it by 4. It will still give you the same count. It will still give you the same count, right? So this is counting the buffaloes by summing up the legs and dividing by 4. And this is counting the buffaloes directly by their head count. Clear? So logically commands can only be grouped by those people, those who have understood how the command really works. And how I can get the next level of output. How I can get the next level of output. So pipeline gives you immense power. Remember, no other operating system other than Unix and Linux has such a fantastic concept of clubbing multiple commands to get a skimmed output, a filtered output using pipeline. Another way to do the same thing could have been, in the absence of pipeline, how I would have done it. Redirect the output to ls output.txt. ls का output गया उसमें. Then I would have said grep caret d from this file, and then I said ls only dirs dot txt. अभी इस फाइल में देखो क्या है, पूरा आउटपुट है. इस फाइल में क्या है, ओनली डायरेक्टरीज है. देन आई से tr hyphen space coming from only directories and redirecting the output is space removed dir list dot txt. अब इसमें क्या है, अनवांटेड स्पेसेस जो है वो रिमूव हो चुके हैं. क्लियर, अनवांटेड स्पेसेस आई हैव रिमूव्ड. And then I am saying cut hyphen d space as the delimiter field number 9 from this file. So the same thing I have accomplished, but every time capturing an output of a command and redirecting it to a file. Instead of redirecting it to a file, you can put a pipe in between. Anyways, the pipe, the output of the previous command will go through the pipeline as input to the next command in the pipeline. Is this clear? Very important. We'll stop here today and we'll continue with command substitution, which is another important theory topic.